Morning, I'm Andrew Cruz. Today I'm joined by Lance Cotahio, Selena Wynn, and Arslan Gold. We're Teammate 81 and our project was a chalk art printer. Chalk art is a popular form of advertising. You can often see it in downtown areas, around bars and restaurants, often on chalkboards, sometimes on the ground. Our goal was chalk art is a great way to bring in customers. It's temporary advertisement. You can change it week to week to attract customers for your new products. The issue is it requires a skilled artist to produce. So our project aimed to reduce the skill required by making a machine that could produce the chalk art. So we based our design around a CNC machine or a 3D printer or a pen plotter, and came up with a few different ways of solving the problem. As you can see, our objective was to be able to produce images on chalkboards or, most importantly, on concrete. So to do this, we initially looked at using traditional chalk, but due to some material properties that we can go over, it was a little bit not the best solution. So we came up with using a chalk pen for non-porous surfaces, and for porous surfaces we use a spray that we came up with. So the system for concrete, we have a chalk-based paint, and we use compressed air to spray it on there. You can see the mechanism on the side there. So some of the things that we're concerned about is size. We needed to be able to produce a large enough image. So there's one there. We can do images of about 4 feet by 2 feet, and we can produce some small details as well. So some of the things that we looked at to grade our images was dimensional accuracy. Can we produce the same size image repeatably? Can we fill the image in? Can we produce small details? And it says here to be determined the angle of reproduction. We passed that a couple days ago. And so the chalk art printer works by taking the user provides an image, we run it through an open source software package, and then we can load it into our machine and print it. So I'd like to open it up to any questions now.
What's angle reproduction mean?
So when you have an image, one of the things that we were worried about, because getting chalk in a fine line is difficult. So being able to produce narrow angles that may show up in an image. So we did this by producing small letters, so 1-inch high letters, and that we were able to do that. And we took an app we drew out a series of letters, and then if an app was able to read it, we're therefore able to produce small angles accurately.
The chalk guns, the liquid chalk spray, did you guys come up with that, or is that something that's already off the shelf?
So the material that went into it isn't off the shelf. That's something we came up with, and we use an airbrush. Those are a painting airbrush, and controlled it with a servo.
Okay.
Through our machine.
And does it have to be? Do you have to put the sign or whatever underneath it, or could you hold it up and do it vertically, like where you'd mark a wall or something?
As of now, we can only do horizontal, but that's just we just have to put it up on a wall to do it vertically.
I mean, the ability to make temporary signs is pretty interesting.
Yeah.
How would the user input the image they wanted to reproduce?
So you can handle JPEGs or anything. We're using a open source software, Inkscape, and it can produce the G code required for the image.
Who did software and who did hardware in this, in your group?
Who did what? Who did what?
Who did what?
So for our letters testing, I did a little bit of the software. It's kind of a group effort on most of it.
For the most part, I handled the interface between our software that sends the G code into the machine and how that G code goes into the controllers and translates into motion control with the motors.
mechanical assembly and transfer from Inkscape to G-code.
Yeah, I help with the image conversions from Inkscape to G-code as well.
Yes, sir.
I know it's the first prototype, but how was the quality of the image compared to an artist?
Well, using me as an artist, it was fantastic.
Well, and
But we actually have some on the ground downstairs that you'll be able to see.
and two pictures there.
Yeah.
We're done, yeah?
They're done with the machine.
Awesome.
Right, one last question?
Could this be expanded to use colors?
Absolutely. And downstairs, in fact, we have some multicolored images